Yeah, this phone does a surprisingly good job.
You must have a lot
It'll
of
be a
gigs.
relic of our
It's like,
time.
Yeah, I got a 256,
okay, yeah, that's.
so I could have a lot. Yeah, I always get the biggest one just because I'm old and still a little nervous about iCloud or whatever. That is, oh no. Okay, so here is, for you guys at home, we're talking about the calculator. Somebody had some issues with like finding roots or whatever, so we're just going to look at that for a second. Just to make sure. So let's just say I come in here and I type in my equation. I will say this, if you ever are a little off, there's a good chance that maybe there's a negative instead of a minus. Sometimes people do that and you don't really notice it right away. I do because I've been doing it for so long. But if you actually hit the negative sign for a minus, it literally, the calculator multiplies them. If there's a negative, it thinks, oh, times a negative. So you end up getting some x to the 7th graph. And it throws everything off and you're like, what did I do? And it's hardly any difference. I mean, look at the difference here. If all I do is change that minus right there to a negative. Look at the change in the graph. I mean, totally different graph. But when you go back and look at it, you're like, what did I do? You know, and you can kind of see it because the calculator puts a times a negative in there, see it? But sometimes it's hard to catch that. So be careful about that kind of stuff. But here's, when you said it was just finding roots. Okay, so when I go to, in Windows, you can see I've already got it at 100. A lot of times you go to your window and it's on a standard zoom, and it looks like a bunch of vertical lines. And sometimes it's a lot worse than this. The only reason I get, because these are so close together right here, you can kind of see it's doing that. But if this root was like there, 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 and there, it would just be, which means it's going way down. Now, you know it only has 4 real roots, right? Or 4 total roots, right? And if I can see it cross 4 times, I'm like, oh, I got 4 reals and no imaginaries. If it only crossed twice, that means either one of 2 things. Either there's a wiggle in there somewhere, which we've talked a little bit about, haven't we? A little bit? Okay, so there might be a wiggle in there representing 2 imaginaries, but there also very well, maybe it may cross over here and over here. So we don't really know, we might want to open it up, but I wouldn't go any further than like negative 30 to 30, because I'm not going to go, I'm going to sneak one over there at negative 5,000. You know, first of all, your numbers would be massive if that happened, and I'm not going to have, I mean, the biggest your number is going to be maybe 90 or 100 or something like that up there. So, if I see all 4 of them and I want to have a better look at, just don't stretch this out anymore, you can see them. I really only need to go to like negative 4 to 7 to be able to see all my roots. Stretch the y's out. So go go to menu, window, and don't zoom out. If you zoom out, then you stretch the x's too and your graph starts looking real tight together. Yeah, don't do zoom out. When you go to window, instead of zoom out, hit window settings, and just go in there and change the y's. So instead of going from negative 6 to 6, I'm just going to throw a number out there because I just like jumping big. Negative 100 to 100. And that's not going to get it all in, but it gets enough of it in where I can do what I need to do. Now I can look at it and go, oh, the min's down here, isn't it? And you don't have to see the min to find it. Your calculator is really great in this regard. So watch this. If I know it's down there, let's just say I'm trying to find the overall min, what we either call the min or the global min, right? Or the absolute min, as opposed to the relative min or local min. Are you following me? So the global min or the min, I'm going to go down here and now watch. Menu, analyze graph, min, and it says, give me something to the left. Even though I can't see it, I can still say, well, I know it's maybe, that would be left of the point, right? So I can just move over there, click, move maybe over here, click, and boom, it spits out. And it even adjusts the graph now, where the old TI-84s didn't do that. And you can see right there, the min would be negative 189.82 or whatever decimal you want. Not the point. And AP is really annoying about that. Sometimes they say, what's the min? They say what the min is, write the Y value. Sometimes they say, hey, at what X value is the min located? Then you write the X value. At what point is the min located? Then you write the point. So you really have to read to make sure you're answering the right question. And then if it comes to a 0, by the way, if finding the min messes your graph up and you're like, ugh, I didn't want the graph like that. Well, write down what you need. You've got a backspace button. Do y'all know that? Right over your escape, top left, you see it? It says go back. So just go Control, go back, boom, back to the original screen. And you can keep going back and changing stuff. And I kind of do that sometimes when my screen gets cluttered. I'm like, all right, I don't need that point anymore. I already wrote it down. Go back, go back. Now, finding a 0, menu, analyze graph, find the root of the 0. And then I'll probably on a test give you something like this and say, just find one of them. I'm not going to make you find all 4. That's just tedious nausea. If you get one right, then you probably know how to find all 4. So let's just say you decided to find this one. Well, you could either, again, you can go to the left, click, and then you can go to the right, or even if you're looking at this and going, well, I know it's somewhere around 3 or 4. You know you can even enter the number. Like I could enter the number 4. You see it pop up on the screen, enter. And it'll do that for you. And you remember, if it gets all clogged up like this where you can't see what you're doing, go over there, click and hold. It'll grab it, pull it down. Oh, there you are. And then you have your X value. And for this, again, the 0 is just that. And if you're annoyed by this, I am too, what should that say there? Should say 0. But what's e to the negative 11 stand for? Times 10 to the negative 11. That means move your decimal 11 spaces to the left. That's a point, 10 zeros and a 5. That's pretty close to 0. But the calculator solves these using Newton's approximations. It's like a calculus-based approximation where it kind of shoots from different sides and gets closer and closer and closer, but just does it really fast. And that's why it doesn't know that it's not a 0. The old 84s used to say that, and then literally right above it, it would say 0. And you're like, then why don't you just say 0? But this one, that's the best it can do. We good? Any other questions on that? And if you do have a question about relative max versus max, relative max, there's 2 definitions. I'm just going to talk about the calculus one. I used to talk the difference, and they're different, and it's annoying. The pre-cal definition says this. It's a relative max if the points leading up to that point have smaller y values, and the points going away from that point have smaller y values. So basically it increased, decreased, and it was at the top there. But the way the pre-cal talks about it is this could be a max. I mean a relative max. But in calculus they say a relative max can't occur at an endpoint. Well, that's kind of an endpoint right there. Sort of, because this is a jump. This happens in piecewise functions. Okay? So there's kind of a conflict in the 2 definitions. So I don't do the pre-cal anymore. I just avoid it because we're heading to calculus. So bottom line, if it goes up and down, there's a relative max. It may not be the max because the graph might do this. And then that would be the max. Or it might just go up forever and then there would be no max, right? But anytime you have an up-down, it's considered a relative max. It might also be the max. Like that's a relative max, that's a relative max, or relative, same as local, but that is the max. Y'all track with me? Okay. Any other questions on that? All right, we good at home? Too bad you can't say no. All right, so here's what we're going to do today, and you might remember all of this first part, but there is something new today that I want to talk with you guys about, and I don't really need that anymore. All right, so do y'all remember the complex numbers? Complex numbers. Who can give me an example of a number that is in the set of complex numbers? Throw one out. There are no bad answers here, trust me. Talk to me. Yes, -4. Give me another one. Pi, give me another one. E, give me another one. Square root of 7, give me another one. 1. -6. 2 plus I. Square root of 5 minus 6i. -8. What am I giving you? Any possible number on the planet is a complex number. It is the set of all the numbers in the universe. Okay? So anything that could be written in A plus BI form. Now, most people look at this and they go, wait a minute, those are imaginary numbers. Well, they are if B exists, but what if B is 0? If B is 0, what do I end up with? Just a real, right? What if A is 0? If A is 0, then you end up with a pure imaginary, right? And we're going to talk about all this breakdown. And then if neither of them are 0, I have an imaginary. So it includes reals, pure imaginaries, regular imaginaries, every number on the planet. And remember, real numbers include rationals, irrationals, everything. So when I say that, don't confuse that with imaginary. This, everything. Now, we don't walk around going, hey, happy birthday, Kate. You are 17 plus 0 years old, right? Nobody talks like that, right? Right? So we just say 17, right? 17, right?
Yes.
Yeah, we talked about it earlier. Okay, so we say A plus BI, but it means everything falls under that umbrella. So what we like to do, we being the math community, we're going to break this up into what? Real numbers and imaginary numbers. And the real numbers, right? Remember, complex is anything A plus BI. So real numbers would be when the B equals 0 and all you're left with is the real part. Imaginary numbers would be when B is not 0. So if B is not 0, then I actually have an I in my answer. Right? Now, real numbers break up into what? Rational, I'm screaming again, and irrational. And I gave you a definition, maybe even Miss Tyree, because it seems like Algebra 2 people know this sometimes too, of rational numbers. Do you remember what it is? And don't give me examples. We'll talk about that in a second. Just the definition.
Any number that can be written as a fraction of 2 integers.
Oh, that's absolutely wonderful. She said any number that can be rewritten as a fraction of 2 integers. A lot of times people say as a fraction, but pi over 2 wouldn't be rational, right? It has an irrational number in it. So yeah, if it can be written as a fraction of 2 integers, like the number 5, that could be written as 5 over 1. -6 could be written as -6 over 1, right? 2/3 obviously is a fraction of 2 integers. 0.25 repeating can be rewritten as 25/99, fraction of 2 integers. So basically any whole number, integer, fraction of 2 integers, repeating decimal, terminating decimal, 2.5 period would be 2 5/10, right? Or what, 25/10, or even a simplified version of that, 5/2. You track with me? So all of those end up being rational numbers, but the definition is it can be rewritten as a fraction of 2 integers. So what are irrational numbers? Numbers that can't be. Listen, you can just, if you define this, then you don't have to define that. You could just say, oh, this is anything that's not rational. But don't do that twice. Like, well, rationals are not irrational, and irrationals are not rational. At least define one of them if you're going to do that. So irrationals are all the rest. What are examples of those? Pi over 2. Did you say E? What else? Square roots that don't simplify. Cube roots that don't simplify. How about numbers that don't repeat or terminate? Now those are the two that people, or a lot of them that people think about, but it couldn't, does this number repeat or terminate? No, it's got a pattern, but it doesn't repeat and it doesn't terminate. Now if I take off the ... it terminates, right? What about, Can't really put a bar over that, right? 1 5, 2 5s, 3 5s. You can see what's going to happen, but it doesn't repeat, and it doesn't, repeat and it doesn't terminate. So I guess those would fall into there. You don't see that kind of junk a lot. And be careful, if I don't put the ... in there, it terminated, right? Then it should be under here. Sometimes I'm kind of dirty like that on a test. Okay, so make sure you are looking for that too. And then imaginary numbers are what? Do they break down into real and rational? Do they break down into rational and irrational? No. I mean, technically, there are numbers that have a real part that is rational or a real part that is irrational. But we don't make that, we just say they're all imaginary. Now, if the A is 0, we do call those pure imaginaries. But imaginaries could be like 2 minus 3i, negative 5i, square root of 2 minus I root 7. It could be any of, as long as it has an I, we say it's imaginary. But if it's pure imaginary, those are like the negative 5i's, 6i, negative 2/3 I, 2i root 7. They do not have a real part added to it. Y'all with me? Everybody good on this so far? Okay, I probably will ask you a couple small questions about that are worth maybe a point or two on the whatever on the test. Make sure you're careful about picking the right designation on these. Okay, now one thing that you don't know is, I'm guessing, that you did not learn everything about factoring that you think you might have needed to know. Now some of that may be because you just didn't learn how to factor everything. But we told you kind of a lie, sort of. We told you stuff like x squared minus 4. If I told you to factor, we said, oh, it's a difference of 2 squares. And you learned that you could factor this like that, right? And then when we said factor this, what did we always say? A sum of 2 squares. We'd say, oh, you can't factor that. It's prime. But the reality of it is you can factor it. All right, and we're going to talk about that today. You just can't factor it using rational numbers. You got to start getting creative. On this, I can factor it. And let me show you why. What if I told you to multiply this out? What do you get? X squared, negative 2ix, positive 2ix, negative 4i squared, which is, oh, it does factor. Who knew? What if I told you to factor this? Oh, no, it's not a difference of 2 squares. It's not a difference of 2 squares, it doesn't factor. Well, let's look back at this. Isn't that really that? It happened to simplify? Well, with that in mind, what could this be? Root 5, root 5? Now, what I just did, instead of factoring over, look, books and mathematicians like to say, over the set. Over the set means, all right, using just rational numbers, this is factored, except I would have written it like this. I did not have to use anything irrational and anything imaginary, right? Or complex. I just used rational numbers. So normally when we say factor, we're saying factor over the set of rational numbers. And that's what you learn in Algebra 2. In pre-cal, we expand it a little bit because we're always trying to find solutions and roots. We want to do a little bit better than that. So here, this would be factoring over the set of rational numbers. But this included not just the rational possibilities, but also the irrational possibilities. So if rational and irrational are possible, I'm factoring over the set of, what did rational and irrational go to? Real. This would be factoring over the set of real. So this would be factoring only using rationals, but if I expand to rationals and irrationals, that's real. And if I expand to, hey, you can use reals and imaginaries, this would be factoring over what? Complex. And I wouldn't want to say just imaginary because that doesn't give me the freedom to use reals and rationals. So if you think backwards, if I have to have a square root, I go, oh, square roots and non-square roots go to real. If I have to use an I, then imaginaries and reals go to complex. And that's what I'm saying when I say words like this. Okay? So just make sure about that. I'm going to practice that a few times with you in a second. But anyway, a couple other things. Do you remember, and I'm kind of just running through some random things to remind you. Do you remember how I works? Or I squared or I cubed? So if you see an I in a problem, there's not much you can do to it, right? We don't want to go backwards and call it square root of -1. It is. But we don't want to do that, right? We want to simplify it. So anything that has a negative under a square root, the I would come out, and the square root of 1 is just 1, so we would just call it 1I. But I would rather just write it like this. But if I ever have an I squared, what is that? -1, because technically, I'm taking that and squaring it, and the square and the radical would go away, leaving me -1. And then I cubed, so I would want to write it like this. I cubed is just what? -I. Why? Because an I cubed is an I squared times an I. So a -1 times an I. And then an I to the fourth is 1, because an I to the fourth is an I squared times an I squared, which is a -1 times a -1. And if I know those 4, then what can I do with stuff like I to the fifth? Start over. So I to the fourth, I to the fifth, is an I to the fourth times an I. So 1 times I is I. I to the sixth is a what? I to the fourth times an I squared, so 1 times -1. And you can see this pattern repeating. Y'all with me on this? So you can see, you can see this pattern repeating over and over again every 4. So what could we do? This is the hard way, but what could we do for something like I to the 27th? That's the easy way. Good, though. She said, oh, I would divide the 27 by 4, and I would just use the 3 and change that to that. And then since I cubed is -1, that's the shortcut. But what you're really doing is saying, okay, I to the 27th is really 6 I to the 4th. That represents 24 of those I's, right? With 3 I's left over. And since each I to the 4th is equal to 1, and 1 to the 6th is 1, I just end up with this. Sorry. Not -1, dang it, -I. Are y'all tracking with me? And feel free to correct those errors so they don't get permanently put on film. Okay? So right here, the shortcut is just saying, you know what? It doesn't matter, right? Nobody cares about how many I to the 4ths are in there. They're going away. And that is saying there's 6 I to the 4ths. All we really care about is how many I's were left over, because that's what's going to do the difference, make the difference. Y'all track with me? All right, what if I get really ugly with you? And I say really ugly, it's not really that bad. What if I said, are you going to take the time on a ciphering test at a math tournament, maybe this year, but probably next year if you're like, want to come back? Are you going to divide a 4 into all of that and find the remainder? Why not? 1, because it's really hard and annoying. And another reason is 4 goes in evenly to 100. 4 goes in evenly to 1,000. So 4 is going to go in evenly, I know, to all of this part. It's going to go in evenly. The only part I'm concerned about is the 27. So on these, all that matters is that now it does not go even into a tenths place. Sometimes it does here, right? But it doesn't always do that. Like if it had been 17, it doesn't go into a 10 as a remainder of 2. It doesn't go into 20, 40, 60. But in this case, I can just say, I don't even need that. Let me just think about I to the 27th. And then I can do what I did just 2 seconds ago. Right? And there's a couple other things I'd love you to know too, but I will get to those a little bit later. Okay? Also, A plus BI form. Now, every time you don't write something in A plus BI form, I'm gonna dot you. Unless it's not worth but like a point, in which case I'm gonna go minus a half. Tell me, what does A plus BI form mean? What has to come first? The real part, right? Has to come first. What has to come second? The part with the I. Now the I, there's some allowances I give you. I got about 10 minutes. There's some allowances I give you where the I can go, and I'll talk about those. Is this A plus BI form? No. You may go, I know what you mean. No. A plus BI form would be -6 plus 3i. Okay? Is this A plus BI form? No, that's very common. Now, it's okay to have something like this, because there's no I in it. That is better if there's no I to have it as a single fraction. But if there's an I in it, no, I've got to split it up. Right? A plus B over C is A over C plus B over C. So 2/3 minus 5/3 I. And here's where you have two options. You can write it like that, or 2/3 minus 5i over 3. So either one of those is okay. I out to the side or I on top. Y'all with me? What if it was 2 minus I root 5 with an I in there? No. Right? But 2/3 minus I root 5 over 3, just like that, that's okay. Or if you want, root 5 over 3, swing the I out to the side. Let me show you another thing that I see all the time wrong. What if I had, I'm just going to sneak this one right here. What if I have 3 minus 7i over 5? This is just classic, horrible holes in your cheese algebra. You got to fix this. I think I'm just going to sling that I out to the side and then go with the sweet -4/5 I. In fact, I've got tears. I'm so sad on that one. Okay? You can't factor an I out unless it has it in both parts, right? So please don't make that mistake. Okay? Just split it up. But you need to put that in A plus BI form, because that's good math etiquette. It's chewing with your mouth closed when you got a big bite in there in terms of math. All right? Okay. So last couple things is, do y'all remember how to rationalize denominators? Everybody remembers that? So something like really basic. If I had an I down in the denominator, what are you doing? Technically by the conjugate, which would be -2i over -2i. But do I really need the 2 in that case? Or even the negative? No, because it's just a monomial. So if all I need it to do is that, and what does the I squared become? -2. And do I leave negatives in the denominator? Some of you are like, no. Yeah, put it out to the side or put it on top. And again, you can leave the I up there or out to the side. But what would happen if I had this? And you have a binomial. Can you multiply by I? You would have to multiply by the conjugate. So 5 plus 2i. And take your time distributing or foiling, whatever it is you have to do. And then down here, what do I end up with when I foil this? Which I'm not going to foil, I'm going to full it, right? Because the outside inside cancel on a conjugate. So I end up with 25 minus 4i squared, which is plus 4, for a total of, and do I leave it like that? Not unless you want to get dotted every time. So break it up to have good hygiene, mathematical hygiene. Right? We okay? Okay, everybody know how to graph imaginary numbers? I think I mentioned this last year. Now you may go, how do I graph an imaginary number on an X and Y plane? I'm sure that's what you're thinking, right? How do I graph an imaginary number? Well, you don't, because it's not an x and a y. But it kind of is like that. So if I have something like 2 plus 3i, technically I can graph it on a real, and you know real, that's a number line. So on a number line, I would go, oh, over 2. Here's the thing though, it's more than just a real number, it's also an imaginary part. So I extend it and have an imaginary plane. So it's saying going over 2 on the real, positive 3 on the imaginary, and that would be 2 plus 3i. If I had something like negative 4 minus I go, all right, the real part would be at negative 4, but it's not just a number line, it's got an imaginary part, so down 1, and that would be negative 4 minus I. Now, if it is a pure real, like 4, well, mark it on the number line. And if it's a pure imaginary, like negative 3i, mark it on the imaginary vertical number line. Y'all with me? And then this might help you now. How do I find the absolute value? Well, what did Miss Tyree tell you about the definition of an absolute value? It was the distance from 0 on a number line. Well, there's 0 on the number line, so what is it really? It's the distance. How am I going to find that distance if I went 2 to the right and up 3? How do I find that distance? Pythagorean theorem. So that distance actually is what? 2 squared plus, not the 3i, because that's a length of 3. 3 squared square rooted. So when you start looking at actual absolute value, which we'll talk about later, that distance actually ends up being 4 and 9 root 13. That's the distance or the absolute value of that. A lot of people think, oh, if it's absolute value, you just make it all positive. No. There shouldn't be any I because it's a distance from the origin or 0 on the number line. Other good stuff, right? And what do imaginary numbers always come in if they're in polynomials? Imaginary numbers always show up in pairs. And what kind of pairs? Conjugate pairs. So there won't be a 5 minus I without a 5 plus I in a polynomial unless you see i's in the polynomial, which we really don't deal with except maybe on a bonus. But, all right, so that brings us to this. And this is the part I've kind of mentioned that I'm going to have to really move quickly. And I probably won't be able to do all the examples I want, but I can at least do one, and I've already kind of mentioned it earlier. So what if I gave you this? And I said, all right, I want you to factor over, which means using the set of rational numbers. Now, can you factor that using just rational numbers? I would think so. Help me out. What would go here and here? X squared and x squared. What would go here and here that would multiply to give me a negative 5, but when I fold it out, would give me a negative 4 in the middle? Negative 5, positive 1. Can you factor that any more using rational numbers or using what you learned in Algebra 2? No. But what if I allowed you to use irrational numbers? Ooh. What's irrational and rational become? What? Real? So if I allow you real, but not just rational, that allows you to go further with this one. Now, I still can't go further with that one because I would need an I. You might remember that. But not on this one. Check it out. I can break that up into x and what? Root 5 plus minus. Right? Middle terms go away. Negative root 25, which is negative 5. But what about this? Can I do that with reals? No, if there's a plus, I need an I, so I'm just going to bring that down. And then lastly, what if I say, okay, I allowed you rationals, and you did your best job. I allowed you reals, which were rationals and irrationals, and you did your best job. But what if I say factor over the set of complex? What does complex now allow you? It also brings into play the imaginaries. Now, I can't go any further with these, and how do I know that? Because there's only one x. right? I broke up x to the fourth, I can do that, x to the squared, I can do that. But I have no, so I'm just gonna drop those down. I have no more x's to split up. But what about this one? X and x, 1 and 1, plus and minus. But what's that going to give me if I stop here? -1. How do I make it +1? I tack on an I, and you don't need the 1 there. And now I get -I squared, which is +1. And that would be factoring over the set of complex. Who knew? Are y'all with me? Okay, guys, see what you can do. And tomorrow, we're going to be putting all of this junk together. You've got a nice little complex numbers worksheet, which is on your assignment sheet. You might even have some book work. Who knows? I don't remember off the top of my head. But see what you can do. You should get some good practice on all this stuff. All right? Good luck at home. See y'all soon. Yep.